Well, hello friends. Welcome back to the program. Today we are going to work on Jakt, which is the new programming language we are developing for Serenity OS. If you're not familiar with it, you can read more about it on my blog right here. I'll put a link to this in the the video description. And basically, it's a new memory safe language to make Serenity OS memory safe. And also solve a bunch of ergonomics issues we have with C++ at the same time. And today we are going to implement weak pointers in the language, or weak references. So first thing we're going to do is we're just going to make a little test program here. And what I want to do is I want to be able to have a class that has, let's say, some function. Maybe it's a thing that returns 5, let's say. And then I want to be able to instantiate one of these things and point to it weakly. So let's try and do that. So let foo is foo. Okay, so now we have one of those foos, and we can of course call foo value on it. Let's make sure that this actually works. There we go. Okay, so then let me type out one of those invocations here. I always forget. Okay. All right, this thing. Yeah, prints out 5. Very good. So what I want to do is I want to be able to have a weak pointer to a foo that gets cleared if the foo goes away. So the syntax for that should be something like this. So weak foo. The type is a weak pointer to foo. And we can start it out in the empty or none state. And syntax highlighting here doesn't really keep up because we're using syntax that doesn't exist yet. Oh wait, it knows about weak. Interesting. So somebody already put weak into the syntax highlighter. Interesting. Well, ignoring that, the feature is not in the language yet, so we're gonna have to implement it. So essentially, I want to be able to create the foo in a scope like this, so that it goes away at the end of the scope. And then we'll assign it to the weak so that while we're inside of the scope, the weak will contain a pointer to this foo. But once the scope exits, our weak foo will reset and point to nothing. So let's see how we would print this. So like weak foo has value question mark, something like this. And then I guess we can also call the value function on it. So we will do a forced unwrap followed by a .value. Okay. And then afterwards down here, we should of course discover that it no longer has a value at the end. Yes. I feel like this is the program I want to run. And then later on, I think I would like the type to actually look like this, just to be symmetrical with our regular optional types, which look like this. So a trailing question mark just means that something is optional. But for now, for simplicity's sake, let's just implement it like this. Okay, so this, of course, does not compile because we don't recognize weak. So let's go ahead and implement that. So I think what I want to do is look at how we've implemented raw pointers, which we already have. For unsafe code, you can do a raw followed by a type, and then that's a raw pointer, which you can then dereference if you make an unsafe block. But for our case, it's kind of similar to that. So wait, is that the only occurrence? No, here as well. Oh, this is ampersand raw. Okay. So the compiler here is written in Rust, by the way, so I'm not going to be nearly as fast or comfortable as I am with C++. We wrote it in Rust because that's what JT, the co-creator of the language, was used to. And now it's just written in Rust, but of course we are going to bootstrap the compiler to yakt soon enough anyway, and then it won't matter what it was originally written in. But at the moment it's written in Rust, so we are just having to make do with that. So I think here we are parsing a type name. So we're going to say if name is raw or if name is weak. Then let's see, and then oopsie. I'm still getting used to VS Code. Here, I guess we want to instantiate a different parsed type for weak or raw, so we'll do like something like this. Just to try to avoid duplicating too much code here, we'll just do something like this. Okay, and then we will add weak putter as a parsed type, which has itself another parsed type, of course. So essentially what we're describing in Serenity terms when we say this is a weak putter to foo. If you're familiar with the Serenity code base, then you know that this is what we usually do. And just a quick note on how yakt works. All classes are always reference counted. So that means that whenever you're passing a class around, you're passing around a smart reference counting pointer. And that's how we avoid use after free bugs in the language. Oh, missing a paren down there, actually. Okay, so of course now we have a whole bunch of things that we have to fix because I added that type. So I'm just going to use this thing here to take me to the first problem. So now we are in type checking, type check the type name. So we're going to type check the weak putter, which is similar to raw putter, I guess. Although, in my thinking, weak pointers have more in common with optionals than with raw pointers, because it's essentially like an optional, just that it has this magic behavior where if the thing that you're pointing to goes away, then the weak pointer clears. But from the outside API perspective, I kind of want it to behave just like an optional. So I think what we're going to do actually in our runtime prelude here, we are going to declare the weak putter type, and we will say has value was something that I used, for example, right? In my test, yeah, has value. So we're just going to say we're going to import this template from the Serenity C++ code that we are using in Jakt, and allow you to instantiate it and call has value on it. So let's try that. Which means that when we're type checking this, we can type check it in the same way that we type check optionals. So what we're doing for optional is basically first we locate the struct ID within the compiler for the optional template. So let me just type that out here. So weak putter. First we parse the inner type name, but then we go and look up the optional struct here. But we're just going to switch this out so that we're looking up the weak putter struct ID instead. And then we'll turn this into a generic instantiation of the weak putter generic type. Yes. I think that will make sense. Okay. And then now I guess we can see what happens if we try to compile. So we get assignment between incompatible types. So this statement here is not okay because this is a weak pointer to foo, and we're assigning a strong pointer to foo, so that's not allowed. And we're gonna have to allow that. So let's go and look for that error message. And actually, I wonder if I'm up to date here. Yeah, seems like I am. Okay. Right, so we are in type check binary operation. And the check that we have here for assignment is very simple. So if the left-hand side and the right-hand side of an assignment don't have exactly the same type, then we just error out. But I think we need to allow assigning a strong pointer to a weak pointer. So we're gonna have to add a little check for that, I guess. So how do we figure out if the left-hand side is a weak pointer? Let's see. We have LHS tie. That's the, you can't, tie is used throughout the code base because type is a reserved word in Rust. So that takes a little bit of getting used to, but that's just what tie is about. Let's see. How do we figure out what the left-hand side is? So we have a type ID for the left-hand side. So we need to look at the project. Wait, do we have the project here? We don't. Okay, so we have to pass the project because the project object has all of the different types. Let me just go ahead and pass in the project here. Project. Okay. So, wait, where was I? Here, right? Okay. So we have project dot types, LHS tie. So that's going to be, in our case, a generic instance, I think. So if let type generic instance of struct ID over which generic template parameters. I struggle with the terminology in programming languages a bit, so bear with me as I say the wrong word for various things. But basically a generic instance, if you look at it, it has the struct ID, which in our case is weak putter, and then it has a vector of types within these tags here. So if you had TUV, you would have a vector with 3 entries, TU and V. In our case, we just have a single entry for weak putter. So that's the one that we are interested in. Let me see. Okay. So inner types, inner ties. Okay. So if it decomposes to that, I think I have to use an ampersand here. All right, all right. We're getting there. Okay, so we know that it's a generic instance of something, and then we have to figure out if it's a generic instance of weak putter. So I guess we need to look up the weak putter struct ID, which we can get from the project. So find type, find struct in scope, weak. No, we need the current scope ID and weak putter. I think this is how we do it. Actually, let me see that I'm doing that right. Find struct in scope. How does other code do this for like optional? Optional struct ID, find struct in scope. Oh, and then there's this fancy .expect here, which I guess will error out if or panic even if we can't find the built-in optional type. Yeah, I'm just going to use this exact pattern instead of typing it out myself. Weak putter. Look up the weak putter. Okay. So now we know the weak putter struct ID, so we can say if let type blah 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 is that. Can you do one of those things here? If struct ID equal to weak putter struct ID, is that valid? You can do that when you match, I know, but it doesn't let you do that here. Okay, there's maybe some way to do that, but I'm not fluent enough in Rust. So I'm just going to check it in here instead. Okay, so now we know that this is an instantiation of the weak putter template. And then our T is going to be the inner ties first entry. So inner tie is inner ties 0. Okay, that's our type ID. And then now we need to figure out if inner type is a class type, because in our case, the inner type should be foo because we are a weak pointer to foo. And then that's what we should find on the right-hand side, and then everything should be okay. So I guess we can match on the right-hand side type. So we'll say type struct and it needs to be a class, not any struct, but a class. Okay, we'll just have a default case like that. Okay. Oh wait, this is not enough. I have to go and look it up in the project types. There we go. Yeah, project types is just a vector that you index by type ID, and it contains all of the type enum values. Going backwards. Okay. So now we have a struct ID, and then that should allow us to wait. So we have a foo here, but we need to know if foo is a type of struct that points to the same struct ID as the struct on the right hand side. Okay. Yeah, bear with me as I bear with myself. So let's see. Wait, what is it that I want to look up? This project has structs as well as types. So I have the inner type, which is going to be a refer to a, okay, let's continue this. So if let type struct ID equal project types inner time. This is the LHS struct ID. Okay. And on the right hand side, if it's a match, if LHS struct ID equal to struct ID, let's maybe name that RHS struct ID just to be clear. I'm sure that I could write this in a much nicer way, but first we make it work, then we worry about looking good. So if they are equal, that means that we should return a success. So this function returns what exactly? A tuple of a type ID and an optional error. So yeah, so we're type checking an assignment operation, and we're just going to say this assignment works out to the left-hand side type, and it's not an error. So optional error is none. All right. Will this thing compile? It did. Okay. And now we are failing here instead because forced unwrap only works on optional. So the bang or exclamation point indicates a forced unwrap. It's a postfix operation which acts as sort of dot value or dereference of an optional. And we picked the bang because it's supposed to indicate, hey, pay attention, because if the optional has no value in it, if it's empty or none, you will crash the program here. So hence the bang to make you perk up and have a look. Now, forced unwrap. Where is that failing? I guess in the type checker. So that's going to be here. Yeah, forced unwrap only works on optional. So we look at what it is that you're postfixing a bang to, and we're only checking for the optional struct ID. So we're just going to copy that and also look for the weak putter struct ID. And this is not going to be a common thing that we do, I think. Like, it's just that I want weak pointers to have the same, sort of the same behavior or the same feeling as optional types. So if struct ID is optional struct ID, or I guess we can, no, we can put that here. Or struct ID is weak putter struct ID. All right. Okay, so now, as you can see, we're getting errors from the C++ compiler instead, which means that the program like Jakt actually produces some C++, but then Clang can't make sense of the C++ just yet. So we'll take a look at what it's actually spitting out. So I'm just going to run Clang format on it so it looks kind of nice. So what was it complaining about? There's no member has value in weak putter, I guess because that doesn't actually exist. So let's just go ahead and add that to our weak putter class. Do we have something like is null? Yeah, we have is null, and this is essentially the same as that. So I'm just going to go ahead and say has value is the same as is null. Okay, so if we do that, we should actually get one less compile error. Yeah, and then there's no value in weak putter. And there's also no make weak putter in... Oh, interesting. Okay, so we can't make weak putter. Right, because we don't emit classes that are weakable, I think. Yeah, so if you look at the generated code here for class foo, this thing right here maps to this class declaration. And as you can see, it inherits from our reference counting template ref counted, but it does not inherit from weakable, which is why you can't create weak pointers from it just yet. But we can easily fix that. So that would be in codegen, where we are spitting out ref counted. So I think what we'll do here is just say public weakable class name as well. Structure name. All right, so let's try compiling that one more time. And yeah, so now we get the weakable inheritance as well, but that didn't actually fix the problem though. No member named make weak putter in. Wait, what? Oh, wait, this type looks all wrong. let's take a look at the code. Okay, so the weak pointer type that we've generated is actually weak putter to non-null ref putter to foo. So that's not going to work. We want it to be a weak putter to foo. So we have to get rid of this part. So I guess we are generating the name in kind of a dumb way. That would be in codegen type, I think. That's the function that prints out a C++ representation of a yakt type. So let's see, if it's a pointer to, or if it's struct, either a struct or a class, then it becomes a non-null ref putter like this. But in our case, it's a generic instance, this thing right here. And I think what we want to do is probably, well, we want to go and find the weak putter struct ID, right? And then for that, we should probably cache the weak putter struct ID somewhere, but let's not worry about that right now. Let's just see what we can do. So codegen type. Let's go ahead and cache the weak putter struct ID, and then we can say if it's a generic instance of a weak putter, if struct ID is weak putter struct ID, then we do special stuff. So essentially we want to do the same thing as a class pointer, so that we say weak putter to namespaced class name instead of weak putter to non-null ref putter. So let's just special case that here, weak putter. And then I guess, oh, this match has to have output at the end because it's, yeah, this thing is so hard to get used to in Rust. I feel like that the last expression within a block is the result of the block. I mean, it sort of, it leads to some elegant situations, but I find it really hard to remember. Okay, so we can't compare those. Can we compare these? Use of class template weak putter requires template arguments. Oh, wait. Am I even saying this right? Should I be doing that instead? Weak putter to weak putter. Oh, yeah, right, of course, because I have to look at the inner type. Weak putter is the outer type here, and then I am just printing the outer type inside. So we need to figure out the inner type, which is going to be from inner ties. So let inner tie is inner ties 0, and then we need to work out the struct ID for the inner tie. So that will be if let type struct ID equal project structs, or no, project types inner tie. And then we'll put all of this stuff in here. Yeah, this is definitely not going to be like perfect or catch all possible errors and things like that. But it's very early for the language, so we're still just trying to get basic features in. Okay, so this feels vaguely like progress, but at least that problem went away. So let's look at the code now, because now we're having new problems. So I guess the problem it was complaining about was .value is not a thing. Weak foo.value. Oh yeah, right. We can easily add that. So we have has value, and then we can also add a value. That's again just for symmetry with optional, which has value and value. Ooh, look at that. our program runs. And it's not entirely correct though, because has value is backwards. It's supposed to say not is null. Hey, okay. So it totally works. So look here. We are, we have a weak foo, which is none at first. So we can actually print that out up here, and that should be false as well. Yeah, so it starts out has value false, and then we create a foo, assign it to the weak foo. Now the weak foo has a value. If we unwrap the weak foo and call that value on it, I guess the value name here is a little bit misleading. Let's just call it hello. Hello. Yes. We could even return something totally different, like friends. Hello, friends. That's pretty good. And then, yeah, and then the foo goes out of scope, and our weak foo is back to not having a value. It works. That's pretty cool. And let me see if I can make a second weak foo, which I will just instantiate from the first one, and they will of course both be null there, but assignment works. And let me see that assignment works here as well. Second weak foo is weak foo. Yeah, so you can assign from, what I really wanted to check was that you can assign from a week to a week. Yes, very cool. Awesome. That was less painful than I thought it was going to be, but yeah, you can clearly tell that I'm less comfortable with Rust, but we were still able to get it working. I don't love the way the type checking code turned out. Where was that? Weak putter struct ID must have been in the binary operation type check. Yeah, this is like, I guess maybe this is just me being new at writing Rust. I just find it really hard to not slide all the way to the right whenever I'm trying to do something. It feels like the language has like an inherent rightward drift. And that's actually something that I feel very strongly about Jakt, that we have to find ways to avoid the rightward drift. So we have to give the programmer tools so that they don't get into these situations. Of course, I'm probably doing something silly here that I could do better. Maybe I could consolidate these things. Actually, maybe if we run that Clippy thing, it will tell me something I should be doing. All features. Nope, okay. So I would like to fold this thing together with this thing, but can I actually do that? What if I would write it in this way instead? So I'm gonna match on project types. Let's see if we can do that. Okay, so now I want to match this thing right here. If struct ID is weak putter struct ID, okay? And then do this stuff. But wait, this didn't actually get any better though. It's still the same nesting. Dang it. Also, I'm not doing something right, clearly. missing arrow over here. Okay. Yeah, I'm not sure if I like match here or if let better. If let feels better, but it also feels silly to nest this thing. Can't I add this thing up here somewhere? Where would it go? Like, I feel like it should go there. Well, that doesn't work. If let. But that doesn't work either. Oh well. Okay, well, I'm not gonna sit here and tinker with that because that's just gonna take a lot of time and I'm not gonna make good progress. So instead, I guess we can come up with some tests for this. So we'll start with the test that I just made, and we'll just copy that into our samples week. So our tests are actually in the samples directory, which is a bit weird. We should maybe consider moving those at some point. But the thing I just made, we're going to put it into samples week basic yakt. And then the way that we test stuff is we run the program and then we take the output, just save it into a file. That is the name of the test, but instead of .yakt, it's .out. So click. And then our unit testing machinery will run the test and verify that the output matches what's in that file. So I think since I added a new directory to the tests, though, I still have to go ahead and I have to add a little thing here at the bottom. Yeah. Samples week, just to make sure that it will actually get run by the tester. And then I can do the cargo test week. And then it ran all the tests in that directory. So we're gonna go ahead and add a little bit more tests, of course. So samples week, assign week to week dot yakt. And then let's go ahead and declare a class. And we will say let foo is a foo. Or we can even do this. Let foo is week foo. Let bar is week. Let bar is foo. Yeah, there we go. This should compile. So we'll just print OK. And let me go ahead and test that out. So that's assign week to week. Oh, damn it. I didn't mean to print the output anywhere. But yeah, it prints OK because it compiles. That was the important part. And I probably screwed up actually the other output now. Basic.out. Yeah, let me refix that. Okay, assign week to week works. That's really good. And maybe we should verify and do a little bit more of a complex test, I guess. So touch samples week. Basic more. Let's call it reassign. Reassign. That's a good name. Reassign. Okay, so let's have a class foo once again. And this time we are going to create two foo objects. So we're going to have foo1 is foo and foo2 is also a foo. And then we're going to have a mutable week foo, and I guess we can start it out pointing at nothing, but then we will point it at foo1, and then we'll point it at foo2. And just to verify that we actually have the right foo in the end, we can do something like, let's just give them a value here. So we'll say 1 and 2. So print line, weak foo, bang dot x. And it prints 2. Very cool. And it should also print 1 while we're here, by the way, just to make sure. Cool. And can we actually clear it by doing that? Then this should crash. We can't assign none to it. Oh yeah, right, because none is special. Well, that's a separate issue we'll have to deal with later. So I think in order, let's just come up with some way to clear a weak pointer so that we at least have one in the language, even if it's not necessarily the final way you're going to be clearing them. But let's just have something like a clear function. And we can add the same to optional just for symmetry, or you know what? No, we're just going to do this and leave that there just so that we have a way to do it. And oh, clear is already a thing actually in the C++ code. So that's okay. So we'll call .clear on it, which should now crash because we are unwrapping it here with a bang. Crash, yeah, that's what you get. That should definitely be a nicer message, of course, but one thing at a time. Has value should be false. 1, 2, false. Beautiful. Okay, so I think we are pretty good with that. Let's make sure that we actually have reference output for all those tests. Okay. Yeah. So adding those things. Yep. All the good stuff. This was actually a lot simpler than I expected. I still kind of don't love this thing. It looks like an arrow going to the right. But I don't feel too bad about it because we're definitely going to port the compiler to Jakt anyway. And I'm sure also that somebody can tell me a better way to do that. So I'm not going to worry too much about that. Instead, we're just going to write a cool commit message here. So that'll be, what's the category for this? It's like everywhere. Support, add support for weak references, or just add weak references. You can now declare a weak reference to T. Yeah, weak T. These are represented as weak putter T in the resulting codegen. I've tried the goal is for them to feel and behave like optional T. Despite being backed by a different C++ class. Weak references can be force unwrapped with postfix bang. Yes. That's pretty cool. And I know we had an issue open about it, so I'm going to reference that because I made an issue about it. Weak references. Yes. And it doesn't have the final syntax here yet. So I'm going to leave the issue open because I want the final syntax to be weak T question mark to be symmetrical with optionals, but let's just say work towards 170. All right. Yes, that's pretty cool. So let's run the weak tests, and they pass. Awesome. Yeah, kick ass. I think that's going to be it for this video. So if you made it this far, then I thank you for watching, for hanging out. I have to admit, I was almost a little bit nervous to to record today because I feel really clumsy when working in the compiler. And I think we still managed to get ourselves out of it. So very, very nice to have weak references up and running. And we are going to keep working on this compiler. And of course, if you haven't read the post about it, please do. But the basic idea is that we are building a memory safe language for Serenity that fits all of our needs and makes the project hopefully more future-proof, and we don't have to spend the next couple of decades debugging avoidable problems. Anyway, thank you very much for checking out the video, and if you want to talk about Jakt, we are in the Discord server as usual. There are Jakt specific channels on the Serenity OS Discord, so you'll find us there. Other than that, it's nice to be back, and I'll see you all next time. Bye.